So we have completed our derivations about complete information. Now let's talk about information asymmetry and see what's going to happen when the agent's type is not observable by the manufacturer, by the principal. So when the valuation is hidden, we know the first best plan does not work. Okay? Because I cannot design my offer by observing the agent's type. Also, I cannot offer a menu of the two offers for the consumer to select. So what does that mean? I know the consumer may be of low type or of high type. I know when he was a low type, and if I can see it, I offer this to extract all the surplus from him. Or if he was a high type and I can see it, I offer this. So this is a collection of my first best offers. And I put it as a menu. That means, okay, now comes the consumer. I cannot see its type. And then I offer these two contracts to him for him to select. Okay? So for example, this may be 5 units, $100, and 8 units, $200, something like that. I give him two pairs of two contracts to select, and he may choose either this one or that one. We hope that the low type consumer will choose this one and the high type consumer will choose this one. If that's true, I can still get everything I may get. Okay, and information asymmetry is nothing. But that's not going to happen because both types will find the low type contract is better. Why? Suppose you are a high type consumer. You see these two offers, you're going to evaluate which offer gives you a higher utility. Okay, and of course you see the high type offer gives you nothing. Your utility will be 0. But the low type is different. You will evaluate your utility function. Your type is theta h, so this is your willingness to pay. And you get a quantity by paying something. Okay? You also know that T tilde L satisfies T tilde L equals theta L VQL at Q tilde L. Okay? This is something you know. You know these two quantities are identical. And then you immediately see that theta h minus theta L is positive. This V function is also positive. So as a type H consumer, you are earning a positive rent or a positive utility by choosing the low type offer. Okay? So this tells us that this is not going to really give us the first best outcome, the first best profit. And it turns out that this particular solution is also not optimal under information asymmetry. So anyway, this strategy will simply fail. We say that this particular offer is incentive incompatible. What does that mean? This happens when one type of consumer pretends to be another type. In this example, if you are high type, you will choose the low contract. Okay? And we say the high type guy is pretending to be a low type. Oh. And this fits our common intuition, right? There comes a consumer. You ask him, do you like my product? They will always say, I hate your product. Okay? They will always say, I hate your product. They will say, I prefer the low contract. And that's going to be their actions. So you cannot make the contract, you cannot make these two offers incentive compatible because consumers will choose the same contract. Okay? So on the opposite side, A menu will be called incentive compatible if different types of consumers will select different contracts. In that case, we say those contracts can induce truth telling, and after we observe the selection, we can identify the type. Okay, so suppose I do not offer these two contracts. I offer something else, and I know suppose low type guys will choose one kind of contract, and high type guys will choose the other contract. Then, according to their action or according to their behavior, I can tell what's their type. Okay, that's something that we may do according to our contract design. So let's see how may we do that. Suppose I offer QLTL and QHTH, and suppose I want it to be incentive compatible. The idea is very simple. I need to make sure that the type H consumer should choose QHTH, and that means by choosing QHTH, his utility should be no less than the utility for choosing QLTL. Okay? Then I can induce, by designing these four numbers carefully, I can induce the high type consumer to choose QHTH. Similarly, for type L consumer, I need to design these four numbers carefully so that I have this condition, I have this inequality, and then the low type guy will find choosing the low contract is better than choosing the high contract. Please keep one thing in mind. No matter what the contract you choose, your type will still be the same. Okay? So at both sides you see theta L. But for Q and T, that depends on your choice. So this constraint is saying for the low type guy should choose QLTL instead of QHTH. These two constraints are called incentive compatible constraints or truth-telling constraints. If your four numbers satisfy these two constraints, your offer will be incentive compatible, and in equilibrium, these consumers is going to tell the truth. Okay, tell the truth. Another set of constraints are individual rationality constraints or participation constraints. They are saying that these consumers should at least get a non-negative utility by choosing the contract that you prefer them to choose. Okay? So as a high-type consumer, I can see by selecting the contract that is intended for me, I can get a non-negative utility. And also, I prefer that to a low-type contract. So I will really choose the high-type contract. Okay? That's something the principal must have in mind. So if I design my offers by satisfying these four constraints, I can really offer an incentive compatible and acceptable menu. But is it optimal? Okay, is it optimal? No one can answer that at this moment, right? So let's continue. The thing is that inducing truth telling is really optimal. Also, I don't know how you feel about this. When the first time I see this, I was shocked. Okay? There are so many different kinds of contracts. There are so many possible pricing mechanisms, right? Some may be incentive compatible, some may be not. And you probably can imagine only a very limited number of contracts are incentive compatible. Most of them are not. But what's interesting is that among all those incentive compatible mechanisms, at least one of them is optimal. This is called revelation principle. So let me say that again. Suppose in the world there are so many different contracts. Okay, so this black circle means all the contracts. Some of them are incentive compatible. Some of them are incentive uncompatible. Okay? So incentive compatible contracts are just part of all the contracts. Among all the contracts, some of them are optimal. Optimal means I offer this menu or I offer this mechanism, and then the agents will act by maximizing their own expected utility. And then I can earn the highest amount of profit. Okay? Then I call them optimal mechanisms because they give me the highest amount of revenue or highest amount of profit. This result is saying that this particular area here, okay, is non-empty. I don't need to investigate or search among all possible contracts. I only need to search among incentive compatible contracts. Within this subset, I find an optimal contract. Okay, within this subset, I find the best contract. That's going to be the best among all possible contracts. That's revelation principle. The best thing to do is to reveal the agent's type. The best thing to do is to reveal the agent's type. This revelation principle has been contributed by many great economists, okay, including Mirrlees, Maskin, and Meyerson. And these three scholars, they got Nobel Prize in economic science, okay, and those works dates back to 1970s. So they established the field of information economics by providing a framework for analyzing the screening problems, okay, and then to highlight their contributions, they were awarded the Nobel Prize in economic science. So that's some related backgrounds. So you can see that the screening theory or the theory about information economics is really something in the economics. So once we apply the revelation principle, the idea is now clear. I only need to search among those truth-telling contracts, and that's going to make different types of consumers select different contracts in equilibrium. And that will allow me to know what they will do. That's the second stage problem, right? And then I can formulate my first stage problem to try to maximize my expected profit, like this. I should design 4 numbers or 2 contracts so that they are incentive compatible and individually rational. Okay, if I have IC and IR constraints, then in equilibrium, high type consumers will choose QHTH, and the low type consumers will choose QLTL. And also I know with probability beta, I see a low type consumer, and the outcome will be QLTL. So this will be my my profit when I see a low type consumer. If I see a high type consumer, I earn TH minus CQH as my profit. So this is my expected profit. I design these 4 numbers to maximize my expected profits. And the best thing is that I know I can impose these constraints to limit my search space. Okay? I am solving this problem to find the best incentive compatible menu. And that's going to be the best menu in the world. Okay? So this is really the seller's problem to solve. So one very significant improvement in this field is of course the revelation principle. If we do not have this principle, we cannot really claim this is the right problem to solve, right? Because solving this problem may not give you an optimal solution. But because we have revelation principle, we know the optimal solution to this mathematical program is just what the seller should offer. Okay, so that's significant. I'm not going to prove this for you, but if you are interested in the idea, I provided the sketch of the idea in the last 2 slides in this video, in these slides. Okay, so that's something you may want to check. In the next video, we're going to solve this problem. Thank you.